In this recording, we're going to be looking at arc length. I would suggest watching this with the recording sector area. Okay, so what is an arc length? An arc length is part of your circle. So it's a proportion of your circle, of the circumference of your circle. So here's the arc length for question 1. As you can see, it is a proportion of the full circumference. Seeing as it's a proportion of the full circumference, we do need the formula for circumference, which is 2 pi r. So if you did 2 pi r, you would get the circumference of the full circle. We only need part of it. To work out the proportion of the circle that you need to do the angle divided by 360. So the formula is theta over 360 times 2 pi r. So for this first one, what is the arc length here? 14 over 360. Your radius is 8. And again, if you can imagine it's a full circle, you can see the distance from the centre to the edge would be 8. So times 2 times pi times 8. I'm just going to type that straight into my calculator and work out to 1 decimal place. That's 1.954, but would round 2.0 to 1 decimal place. Now for the second one, might appear on the non-calculator paper. So it might ask you to give your answer in terms of pi. So here we have 120 over 360 times 2 times pi times the radius, which is 18. So without a calculator, I would suggest to simplify your fraction first. I'm going to divide both the numerator and denominator by 10, which gives you 12 over 36. You need your highest common factor. Highest common factor is 12. I divide them both by 12, I get 1/3. You could have done that a slightly different way, but hopefully you've still got it simplified to 1/3. I'm going to work out as well, 2 times 18 is 36. So we've got 1/3 times 36 times pi. 1/3 times 36 is exactly the same as 1/3 of 36. So 36 divided by 3 is 12. So the answer is 12 pi. I would suggest having a go at these 3 questions. Third one is a no calculator question. So you put me on pause, answer them, unpause and see how you got on. Okay, so for this first one, it's just typing it into the formula, which is theta over 360 times 2 times pi times r. Doesn't say, but obviously we are working out the arc length, because that's what we've just been discussing. So the first one, 150 over 360 times 2 times pi times 19 gives you an answer of 49.7. The units are centimetres because it's a length. So your arc length here is 49.7 centimetres. For this one, 73 over 360 times 2 times pi times 25.2 gives you an answer of 32.1 centimetres. Again, it's for your arc length, so it's just that part there. This is without a calculator. Yeah, we're going to find our arc length. So simplify your fraction first. Highest common factor is 36. If you divide them both, the numerator and denominator by 36, we get 1 at the top. 10 on the bottom. I'm going to do 2 times 70 is 140. So it's 1/10 times 140 times pi. 1/10 of 140 is just 140 divided by 10, which is 14. So the answer is 14 pi. Now, sometimes you do get some more complicated questions where you have to reverse. You're given the answer and you have to reverse the calculation, the formula to get your x. I'm going to do this one to show you how to do it, and then I'll give you a few to have a go at by yourself. So this time we're actually given the arc length and the radius is missing. So let's put it into the formula for arc length. Angle, theta, over 360 times 2 times pi times the radius is equal to 50 centimetres. A few different ways you can do this to reverse this calculation to make R the subject. I like to bring the 360 over first. Opposite of dividing by 360 is timesing by 360. So if you times both sides by 360, right hand side becomes 18,000. Left hand side, the 360 disappears. So we're left with 20 times 2 times pi times r. Just going to tidy this up a bit. 20 times 2 is 40. So we have 40 pi r is equal to 18,000. Now the opposite of multiplying by 40 pi is dividing by 40 pi. So I'm going to divide both sides by 40 pi. Which gives you your radius. Quite a large radius here. 143 centimetres. Let me just check that answer. It's always good, if you're unsure, to put it back into the formula, see if it works. If you're going to round one decimal place, it'd be 143.2. So let's see, 20 over 360 times 2 times pi times the radius. Yeah, does give you 50. Okay, have a go at these questions here. Calculator, calculator, non-calculator. Put me on pause and then unpause to see how you get on. Okay, for this first one, we've got 237 over 360 times 2 times pi times the radius, which is x in this example, is equal to 9 centimetres. So we're given the arc length is 9 centimetres. This is the arc length. Again, I'm going to times both sides by 360 first. Which gives us 237 times 2 times pi times x equals 3,240. I'm going to tidy up this a bit. So 237 times 2 is 474 pi x equals 3,240. Let's divide both sides by 474 pi. Gives you your answer as 2.2 to 1 decimal place. This time we've got a missing angle for question 2. So it's theta over 360 times 2 times pi times 27. equals 56. Again, I'm going to multiply both sides by 360 first, which gives you theta times 2 times pi times 27 equals 20,160. But tidy at the left-hand side, we get 54 pi theta. We're making theta the subject. We don't know what the angle is. So let's divide both sides by 54 pi. Gives you an angle of 118.8 to 1 decimal place degrees. This is a non-calculator question. So we've got 40 over 360. It's your radius missing in this question. So times 2 pi x equals 6 pi. Okay, let's simplify this fraction first. I halve both of those, we get 2 over 18. Halve them both again, we get 1/9. Well, you could have just got that straight away by noticing 4 is the highest common factor, dividing them both by 4, we get 1/9. Let's multiply both sides by 9. Multiply this side by 9, we get 54 pi. I divide both sides by pi next. Divide both sides by 2. X is 27 centimetres. Okay, thanks for listening.